let's go through this instruction in detail. Now, I've pretty much picked this out at random, but I've just picked an instruction which is quite complicated. So we will talk through how the actual instruction works here within the memory, and then we'll go through and look at how we define the register transfer logic, which really is just how we enable and set all of our registers. So this is going to give us the microcode that we need in order to build up the instruction. Now, the instruction is to add two things together. So the way our instruction works is we're going to have our opcode, we're going to have our source register and a destination. So what we do is we add from the source into the destination and we save the value in the destination. So it means that the value that was in RB gets overwritten by the answer. So if we had, say for example, add 2, 3, then the answer would be 5 and 5 would be stored in RB. Now we know that we're adding the two values together and we know that the destination is going to be RB, so that's quite simple. But to find the operand that we're going to actually do the addition with, we're going to have to look at this addressing mode. So we've got the square brackets. If we've got square brackets, we know it's a pointer. And then the plus at the end means that we're going to have a post increment. So let's say, for example, register array contained the value 200. Now remember, register array means any of the 16 registers R0, 1, 2, 3, 4, 5, the floating point unit, the instruction address register, and so on and so forth. But most usually the numbers will be sitting in the temporary register. So for example, R0, 1, 2, 3, 4, and 5. So we've got the value 200, but we have to go to address 200. So we go to the address 200, and then we have to go into that address to find the value. So the value in that address is 203. Now for the moment, just forget about 204 and 205. Now the 203 is a pointer. That's why this is called a pointer. It's a pointer to another memory location. So the new memory location is 203. So we have to go to memory location 203, and then we have to go into this memory location to pull out our operand. So now we have found our operand, and that value is 40. We have to take that value of 40 out and then add it on to the contents of register RB. Now let's say for the moment that register RB contains the value 20. Then we're going to be adding the value 40 and the value 20, which gives us the value 60. And we're going to place the value 60 into register RB. And remember, register RB can be any of the 16 registers. So that's how we're going to do that, but there's one other thing that we have to do at the end, and this is the post increment. In the post increment, we're going to add 1 on to the contents of this memory location. So we're going to change the value 203 to 204. Now it means that if we were to use this same command again, then this point here would be pointing to the next memory location, which would be contain 41, and then we would add 1 onto that value here to give us 205, and the next time we used it, it would be pointing to location 42. So that's us work through our pointer with a post increment. Now I've noted up here in this line here, these two lines, the address and the value. So the address ultimately that we're interested in, you might call this the effective address. The actual address we're interested in is address number 203. And the contents, or you could call it the operand we're actually interested in, is the contents within that memory location, which is the value 40. So that's us talk through how the command or the instruction works. What we want to do now is work through all of the lines of our microcode. So each of these lines has got an enable, so they've only ever got one enable, but it may have multiple sets. So if you remember back to our CPU, we're going in our old control unit, we said our positions 1, 2 and 3 were our fetch, and then the positions 4, 5, 6, 7, 8, 9 and so on and so forth are going to be our execute. So each of these lines here represents one part of the execute phase. So that could be position 4, 5, 6, 7, 8 and so on and so forth. So we can see that we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this complicated instruction is going to take 10 micro instructions in order to generate it. So let's talk through these micro instructions and we'll see how this is built up. First of all, we have to get access to the contents of register RA. So we can take register RA and enable it onto the bus. So RA contains the number 200. There it's there. So we put 200 onto the bus. But then we want to point to that memory location 200. So we set the memory address register. So memory address register set will contain the value 200. So now we're pointing to that memory location. Now we have to get access to the contents of that memory location. So we set the CNTRL at enable. So that enables the value 203 onto the bus. Now, in order to work with this, we're going to have to take that 203 and save it somewhere temporary. So we're going to save that in register R6. So we have register R6 set. Now, remember I mentioned in a previous video that register R6 is a truly temporary register. And now we only have access to it whenever we are generating this microcode. So it's a register set aside specifically for us generating microcode. You don't have access to this register from the instruction. So in effect, the register becomes invisible. So you can't see it as far as writing your assembly language code. You can't write into register R6 and you can't read out of register R6. It's in effect invisible to you. But it's not invisible to you down at the micro architecture or the micro instruction level. Okay, so that's why I've set it up like this, so that we can use it specifically for these types of awkward and long addressing modes. So now we've got the value 203 sitting in register R6. So what we want to do now is actually go down to memory location 203. So what we can do then is we can enable that value 203 onto the bus. So now we've got 203 sitting on the bus and we want to point to that memory location. To point to the memory location, we set the memory address register. So now we're not pointing at 200, we're pointing at 203. Now what we want to do is take the contents of 203, which is the value 40, out and put it into the ALU for addition. So we can say CNTRL enable, so that will put the value 40 now onto the bus. And what we'll do is we'll set it in the TMP register. Remember, the TMP register sits just above the ALU. So the ALU's got two inputs, and above one of them is a temporary register. So we're saving this value 40 in this temporary register, and we're waiting for the next value to come along to the other input. Now, the other value it's going to get is going to be from reg B. The reg B is going to contain our value of 20. So we enable this value onto reg B. So now at the top of the accumulator, we're going to have our 40 here from position 203 in memory, and we're going to have the value 20 from the register RB. So we're now in a position to do the addition. So in order to do the addition, all we have to ensure is the ALU is set properly. So in addition, the 4 lines that get into the ALU from the control unit will be sitting at 0000. So at this point, the addition has now actually been done. We can set the value in the accumulator. So it's taken the 40 and the 20, added them together, got a value of 60, and it saved it in the accumulator. So at this point here, we're also going to set the flags. Every time we do an ALU instruction, we always set the flags. So that's us work through, and we've got our value of 60. But we want to actually put the value of 60 into register RB. So what we can do is we can enable the accumulator because it's now got the value 60 in it. So we enable that value 60 onto the bus. And we save it in Reg B, so Reg B gets set. So that's us going through the addition phase. What we want to do now is we want to go through the post increment. So to get through the post increment, we're going to have to get access to this value 203. Now to get access to the value 203, note that we're now at this point in time, the memory address register is actually pointing to this position 203. But we don't want to point to the position 203, we want to point to the actual memory location 200 and then pull out the value 203. So you can see here the very first memory address register set pointed us to here. The next memory address register set pointed us to here. But now we're going to have to point back to here again. So to point back to here again, what we can do is we can say, well, we'll enable Reg A onto the bus because we know Reg A's got the value 200. So Reg A gets enabled onto the bus, memory address register gets set. We're pointing to this memory location, and we point to this memory location, we can then enable that value onto the bus. So it's CNTRL enable. So we're taking 203 onto the bus. We take 203 onto the bus. Now, I go through a different addition option here. What we can do is we can set bus 1, because bus 1 will put a 1 value into the top of the ALU. So we'll be taking the 203 and we'll begin to 1 branch of the ALU, and the value of 1 is going to go into the other branch. And again, we're going through the ALU, which is the addition, and we set the flags. It'll take the 203, it'll add 1 to it, and we can enable, set that in the accumulator. So it should here actually, we should have accumulator set as well. So I'll just make a note of this here. So in here, we're actually going to have slash accumulator set. Okay, so it sets that value 204 in the accumulator, and then what we can do is we enable that value onto the bus. So 204 goes onto the bus, and we're still pointing to this memory location 200, so we can just say the CNTRL set. So we set that value into our memory. So now we've got 204 in this memory location, and finally we can go to the stop. So you can see here that the flow, or the control of the flow, can get quite complicated and it can get quite confusing. And there are sometimes as well better ways of doing it. You know, you might do it 2 or 3 times until you get the quickest or the best way. But that's all for this video. We're not going to go through another one like this in this kind of detail. If you go to the spreadsheet, you'll be able to pull out all of the zeros and ones that are associated with the microcode for each instruction, and you can work through them yourself and see how they work. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.